Hello, everyone, and welcome to this webinar, which is co-organized by the WMO Infrastructure Department and the World Bank's Global Facility for Disaster Risk Reduction and Recovery, or GFDRR. Today, we'll be focusing on part of a report published by the World Bank on charting a course for sustainable meteorological observation networks in developing countries. The report also covers hydrological observing networks, but today we'll focus on meteorological observing networks. My name is Albert Fisher. I'm director of the WMO Integrated Global Observing System in the Infrastructure Department at WMO. And just a little overview of the order of the webinar today. I will give a few slides of introduction and context from a WMO perspective, and then I'll turn over to our guests with a welcome from Vladimir Tsurkanov, head of the GFDRR HydroNet program at the World Bank. We'll turn to our two main speakers, David Grimes, who's the former WMO president and former head of the Meteorological Service of Canada, and Brian Day, Chair Emeritus of HMEI, the Association of Hydrometeorological Industry, and Vice President of Campbell Scientific. Then we'll turn to moderated discussion and a little bit of housekeeping, so please feel free during the presentations to ask your questions in the chat field. And when we get to the discussion, please feel free to raise your hand. Meanwhile, please do keep your video and cameras off. And during the moderated discussion, we will have our speakers, as well as David Rogers, who's the former Chief Executive of the UK Met Office and a contributor to the report, participating in the discussion. So without further ado, let me just jump into a few slides of introduction from a WMO perspective, where we are really working on a value cycle or value chain that starts with observations from the entire globe, exchange of that data, the incorporation of that data into global numerical weather prediction products, which enables a host of local data processing, forecasting, warning and advisory products, and the national delivery of weather and climate services, which leads ultimately to effective decision-making and action on the ground. And it's that global meteorological infrastructure part that the Infrastructure Commission and Infrastructure Department of WMO focus on. One of our initiatives in this context is the Global Basic Observing Network, which is very much focused on providing the key and essential data for global and numerical weather prediction for weather and climate. It's been estimated, in fact, in another study published by the World Bank in cooperation with WMO, that the potential benefits of full implementation of GBON in countries with some of the largest data coverage gaps is estimated to be around 5 billion per year, focused just on the improvements, estimated just from the improvements in weather prediction. And so the economic impact of climate analyses, for example, for adaptation, are likely to be even higher. GBON responds to, really focuses at the moment on surface and upper air observations from land of the atmosphere, and really respond to persistent data gaps in some parts of the world. As part of the response to GBON, WMO and several other organizations, as well as donors, have created the Systematic Observations Financing Facility, SOF. SOF was established quite recently in 2021 as the United Nations Multi-Donor Partner Trust Fund, and created as a mechanism to provide that global public good of GBON. It's going to provide long-term technical and grant-based financial assistance to enable countries to acquire and to exchange that basic and weather and climate analysis observations, GBON, and focuses on the sustainability of the investments by producing, by providing open-ended results-based finance upon verification of data sharing without an end date, particularly in mind. It prioritizes small island developing states and least developed countries to close the largest data gaps that you saw on the slide before. And it works through 3 phases. All phases of soft support are open to SIDS and LDCs, and the readiness phase is open to middle-income countries as well. In the readiness phase, we analyze the GBON gap and create a GBON national contribution plan. This is done together with a peer advisor, which is another Met service, could be from the global north or the global south, that helps the beneficiary country identify the gap and come up with a plan to fill it. An investment phase that involves implementing entities, as well as the peer advisor and the beneficiary countries, and an ongoing and open-ended compliance phase where results are provided, finance is provided for the result, which is data that is shared in GBON. So the work we're going to hear about today is very useful in this context as a background to this. So coming back to our guests, I'd like to turn the floor over now to Vladimir Tsirkanov, the head of the GFDRR Hydromet program at the World Bank Group, for a few words of introduction.
Thanks very much, Albert, and good morning, good afternoon, and good early morning to some. I see that some people are as far as New Zealand joined our webinar. And thanks also for WMO to organizing this jointly with us. My really introductory remarks will be very few, just for those who not regularly talking to the World Bank, just to let you know that this institution deals with a number of development issues. And our objective, of course, is reduce poverty. It's about increasing shared prosperity. And recently, we also contributed to supporting global public goods. And of course, Hydromet, which is, in short, what combines in meteorology, hydrology, and climate, is one of those areas. And the bank started to be involved in this area for some 20 years. Last 5 years, our portfolio is stable around $1 billion over the 60 to 70 countries, depending how to count. But unfortunately, in this positive sort of outlook and attention to this area, the results so far are not that promising, particularly in this area which we will discuss today. Of course, many PRs, many heads of NMHSs, when we start developing projects, their first request is, we need more observation networks, which is fully understandable and absolutely justified, because it's a backbone of any value chain, which, of course, Albert showed on his slide. This is indeed a backbone, but problem is, as soon as we jointly with country invested in modernization, few years after, we see most often poor results. And part of the reason, besides, of course, systematic underfunding, lack of staff, etc., was lack of knowledge, what it takes to do it properly, starting with design and then the whole process, how many people, what qualifications are needed, what are the financial resources to make system work. So that's what we try to respond in this study. And again, we were interacting with developed countries, trying to get benchmarks, which is not easy. Benchmarks about what it takes, as I already mentioned, to run the system sustainably. And this will be, of course, presented today by David Grimes and Brian Day, who were already introduced by Albert. I probably should also notice that those countries which provided those benchmarks, of course, all developed countries where the data is more or less reliable. And we worked with Austria, Australia, Canada, Germany, and UK. So this data, which you will see later on, came from these countries. But I would encourage those who are on this call to do more in terms of recording, properly recording this this financial and human part of this business, because what we found in collecting this data, and that took over, I would say, about 2 years to collect this data, it's very problematic. So please do it. But overall, let me stop here. And again, I hope that the results will be of interest to you. We will be ready to respond to any questions. I personally may respond if you have questions about the World Bank, but my more technically sound colleagues, two Davids and Brian, will be also able to respond. Thank you with that. And back to you, Albert.
All right, well, and I'll immediately turn it over to David and to Brian to give the presentation. David, you're muted. David, you're muted. We can't hear you.
Now you can hear me. Sorry. All right, perfect. Yeah, so let's go to the next slide. Vladimir kind of outlined the motivation for this study. it really has to do with a lot of the initial investments that go into these networks actually fail prematurely. And so we tried to understand, and it's been a long, at least 5 to 10 years, the bank's been looking at this question of sustainability and how to ensure these investments are maintained. So essentially that was the motivation for the study. The report was kind of organized in 3 parts. We kind of have a pathway for sustainability, looking at what were the ingredients of success. And then we looked at hydrological recommendations for hydrological systems for building sustainable networks, and also for meteorological. And as Vladimir mentioned, we're just going to talk about just the first and the third today. So next slide, please. So the introduction, and particularly the introduction to SOF, already recognizes the value of hydrometeorological data. So as developing agencies support countries, or SOF investments go in to support countries, the real objective is how this would be maintained over a number of, over its full life cycle. I'll talk about that in a minute. Observational data, hydrological and meteorological observational data have huge value to society. And it kind of goes beyond the 5 billion US. We looked at that study during this report, because it also supports the environmental dimensions, such as ecosystem functions and biodiversity. Very important when you kind of understand how we as a planet kind of are evolving. So it goes beyond sort of the weather and the climate and the immediate impacts, but it also has these long-term benefits. Next slide, please. So we looked at the in-depth in the study at the sort of the root causes of what was breaking down, and primarily the 2 that stood out were the insufficient ongoing resources, not necessarily the initial investment, but shortly during the life cycle, these systems would fail because resources weren't made available. And the second primary reason had to do with human resources and the staffing issues, the turnover, lack of succession development. The competencies weren't very well aligned to the systems that were being put in place. They got some initial training, but sometimes the staff would move on to some other tasks or other play other roles. And so those 2 were the primary areas. But it was also, when we looked at this, we saw that the connectivity with government in stressing the value of observations, it's a little bit like thinking of this like plumbing. The value of plumbing to all of us is pretty important, yet it's not visible. And therefore, how we communicate the value of observational networks to government was one area that was area to improve. The second, the next area had to do with unclear roles and responsibilities. The World Bank has been doing a lot of work in looking at how to establish clear roles, national legislation or laws, etc., that would articulate the importance of national meteorological and hydrological services. And then we would also look at, in some cases, there were examples where the advocacy from users about the value of the network, primarily to government, was not particularly strong. And finally, there was this kind of absence, really, of this kind of non-holistic planning for network modernizations. And so this kind of led us to thinking about what were some critical design principles around affordability governance, workforce competencies, engagement, and institutional arrangements. Next slide, please. So we came up with this kind of vision, and this is sort of a graphic that kind of that talks about the three critical components of that. The first had to do with mapping context and knowing how, knowing your network needs and uses, the state of the network, expected life, of the existing monitoring infrastructure. In some cases, we found that development initiatives added new stations, but didn't necessarily provide support or resources to maintain the existing ones. And the existing ones were not always integrated as a component part of kind of that whole, so that kind of holistic look at networks. And present and future budget limitations and expectations. Clearly, this was the study sort of looked at surface, upper air, and radar in a meteorological sense. And it was seen that radars are extremely valuable, but the budgetary requirements are significant, and I'll talk about that shortly. But this idea of understanding what your budget is and what your budget would be in supporting these kind of networks going forward, very important kind of consideration. Your existing workforce capabilities, like what your technical capacity is, how would you be able to support maybe an automated upper air system or a radar. These are important considerations at the very beginning of a process. And then understand the potential for network partnerships. And we talk about this, I'll talk about this a little later, and Brian really goes into this in more depth. So the second component was understanding total cost of ownership and affordability. So this is kind of the affordability component. And it has basically four components. It's understanding what the capital costs for procurement implementation, and those are usually defined at the beginning, and they're usually well done. Ongoing operating costs, these are important considerations, yet this is an area that we felt there needed to be a stronger focus for improvement. This is also in support of maintenance and the maintenance cycle and the costs associated with that. But the last part, this kind of life cycle management and recognizing this kind of depreciation and residual value. This is actually extremely important, because at the end, if you do investments, and Brian will talk about this in his part, do some mid-life investments, you actually can prolong the state of these networks going forward. So understanding these four component parts is important. Next slide, please. And so when Vladimir talked about some of the benchmarking we did, we actually got, I don't know, there was about 60, 70 countries financial data where we were able to recover it. We looked at those operations which were, I would say, successful at being able to sustain their networks over time. And really, we wanted to understand what were those kind of component costs for each one of those areas I've just talked about, those four parts. And you know, what we found when we started to do a comparative with the country data that we did receive from middle income or low and middle income countries, which is the graphic on the left, where you can see that when you compare that to the sort of the operating costs, and even not taking into consideration labor costs, you can see in those orange bars for both upper air and surface and radar, there's a gap between what the average expenditures were in those upper middle income countries and what the investments were in countries that were trying that had better success at maintaining these over a period of time. And so this kind of led us to then try to understand that. The little box on the top talks about the full-time equivalents or the staffing levels that you need to support these kind of networks. And we also did a comparative, and in some cases, in the surface, for instance, there were probably more staff dedicated to the surface weather than you would see in let's say, against the benchmark countries that we looked at. And the primary difference, I think, is that a lot of those developing countries were in this process of moving from manually based observations, although we did make the distinction between manual and automated. So, but when you looked at upper air, or you looked at radar, and radar in particular, the full-time equivalents needed to be greater. So next slide, please. So this kind of gives you what this is in the report, and it's sort of documented, but this gives you a perspective in US dollars of what the cost of the different systems are, the initial investment capital costs, the operating maintenance, the full-time equivalents required to support them, and on a per station basis, and then the life cycle of these systems, and the annualized replacement costs. And so in life cycle, you need to understand eventually you're going to have to replace these systems. So by understanding what those costs are on an annual basis helps you makes a case for, say, early intervention that extends the life, and Brian will talk about that shortly. So the next slide. And this decision considerations it's kind of led us to what would be the decision considerations around creating a sustainable or building sustainable networks going forward. And I mean, the first dealt with this kind of fit for purpose, but aligned to budget. So this is kind of whatever you design needs to be fit for the budget that you have available or would have available in order to do this. The second key consideration in that box had to deal with stepwise priority setting. And instead of saying, well, I need 50 new stations today, and go and get 50 new stations to add to your existing network, is what are your priorities for either upgrading your existing networks or increasing or taking on 10 or 15 because they would be affordable. And then the second was make or buy business models, and I'll speak about that in a minute. The efficient structures and legal frameworks, we have talked about that in the World Bank. That's been a common topic. Important to have clarity of roles and responsibilities, particularly for public sector functions that are provided by national meteorological services, for instance. And then a systems of systems, thinking about how you leverage actually partner contributions, and then investing in workforce capabilities. Next slide. Okay, so in the understanding business models, in one of the benchmark countries we looked at how they supported radar. So the National Meteorological Service didn't actually own the radar. It was owned by some other organization. And the value of that was, so this would be an example where it's third-party owned and third-party operated. So what they would then do is provide a service to the National Meteorological Service, one to the National Hydrological Service, another to the Department of Agriculture, and several other organizations in government and in non-government. And what that did was distribute the costs of operating that network across different entities, rather than just having the one just being government owned and government operated. And then so it was important to think about what are the advantages and disadvantages for when you introduce new systems about whether you operate them or whether you have them operated by a third party or whether you do them through a sort of a public-public or public-private partnership. And the case I just gave you, although that was third-party owned, third-party operated, it behaved more like a partnership. And this shows effectively factors to consider, which is kind of affordability and readiness. Your ability to be able to maintain and support those kinds of networks tells you, this gives you a bit of an algorithm to determine what would work best. So if you can skip down 2 slides. Under leveraging partner contributions, extremely important. And this is kind of in this kind of co-design, co-production, co-management. So if you're going to have an increase, let's say, modernize a particular network, there may be examples where partners that are operating may already have networks that might actually fill your gaps, or there would be, let's say, some potential to consider how you might do this with all of your partner organizations together in designing how that network is laid out. This was actually one of the examples we took from the UK, where particularly in supporting emergency measure organizations, where they actually looked at how to develop design their networks in a way that looked at what partners contributed, but also in the expansion of networks, how they were done in sort of a co-design, co-produced, sort of a co-production or co-management of those networks. And next slide. And so I think this slide is pretty clear. It's really important to invest in the development, career training, and leadership skills. Networks are becoming more complicated. The systems are becoming more complicated to be able to maintain and support. In some cases, the costs for maintaining these are getting higher. And so it's really important to sort of understand and develop your staff capabilities in order to be able to maintain these networks over the next 10 years, which includes effective succession planning, ensuring that you have a good flow of staff into those roles and making those jobs attractive. And given the importance of the function, these are really high valued functions that are in a public good, and they need to be well communicated to government, who are often the ones that compensate or determine the level of compensation for staff in National Meteorological Services. So with that, I'm going to turn it over to Brian.
Thank you, David. I think you've done a great job of setting the stage as to why the systems have not achieved the expected results. And I want to look at some of the more practical aspects of sustainability and how we can fix some of these problems. Part 3, the recommendations of sustainable meteorological observation networks, covers about 150 pages, and that may seem a bit intimidating if you want to read it all, but I'll break it down for you very quickly. The executive summary gives you a basic overview of the problems and how we can go about fixing them. The overview, part 3.1, talks quite a bit about what David has mentioned, but where I would suggest start to read is part 3.2, network planning. And we'll go into more depth about network planning, and then we'll talk about part 3.3, which is the total cost of ownership of a weather observing system. After that, you need to look at the observation network that you're wanting to invest in, And we have 4 different ones: the automatic weather observing systems for aerodromes, automatic weather stations, upper air systems, and weather radar. And it's interesting that we don't see the same problems with AWOS systems as we do with the other 3 in terms of sustainability. And that's because aerodromes have a revenue stream for landing fees and takeoff fees that usually gets, some of that money gets invested back into the system for ongoing maintenance and life cycle management of the ground stations. And then at the end, there's a total cost of ownership, which you can go through after you've created, done your network plan. Next slide, please. So I wanted to break down the title a little bit because it's sustainability of a system fit for purpose, fit for budget. And when we consider what is sustainability, we targeted a minimum of 90%, and that would be for a new network system that was freshly installed, and maybe for the first couple of years, it should be achieving 90% data recovery, 24 hours per day, 7 days per week. In the developed world, we were seeing numbers of greater than 95%, with the exception of weather radar, and that was a problem with one country that had 5 radars. One system was down for a year, simply because it happened during COVID, which is when we took most of the data, and there were supply chain issues in getting the parts. But that country also targets 100% operation or uptime for its weather radar. When we look at the developing countries, some countries are actually achieving that 95%, but it is a minority. More than 50% operate below the 90%, and the majority of that 50% actually are operating well below the 80% uptime or performance level. So not as sustainable as what we're seeing in the more mature networks that we analyzed from the developed world. Next slide, please. So when we take a look at the total cost of ownership, we're very good at developing the initial investment, which includes the equipment, the civil works, the cost of supplier services, and the internal project costs. When we look to the right of the red line, the total cost of ownership, which is the annual operating costs, maintenance costs, replacement costs, and lifecycle management costs, David articulated that we're not doing as good a job at developing our understanding of what it takes financially to operate a network. And so we'll go through the process of understanding how each of the 10 steps of the network planning contribute to this concept of the total cost of ownership over the lifetime of the equipment. Next slide, please. So I won't spend too much time on this slide. David showed some of the data from the developed countries that we benchmarked. When we look at the initial capital costs, as well as the annual operating costs, none of those costs shown have a labor component built in, because labor is different throughout the different economies of the world, and each country has its own sort of baseline set of labor costs. Even in the developed world, we found some big differences between countries. But it gives you an idea of what the initial capital costs are for each of the systems, fully installed and operational, and what the annual operational costs are. I'll just take a quick look at upper air, and it's one of the most expensive systems to operate. And that's because of the cost of consumables. If you are hitting the GBON target of doing 2 launches per day, it costs about $200,000 a year for the consumables of balloons, lifting gas, the payload, to carry out those operations. And for an upper air manual system that has an initial capital cost of $1 million, we're around 4 times that cost over its entire lifetime of 20 years. And so the goal is to get our systems to operate to the lifetime in years that's expected of them. In the bottom left, as I said before, we understand the initial investment, but it's this cost of operations that needs to be balanced against the initial investment. And that's where we need to understand the total cost of ownership. Next slide, please. Much of this is known, but I thought we would do just a quick review of the 10 steps that we identified that are required for network planning. And this is where the second part of our title comes from: fit for purpose, fit for budget. And so the 10 steps, the first one, you have to be really clear in defining the purpose of the required observation network. You have to know what you want to see on your computer screen that's going to help you get the insight into the environment, be it an early warning system or data for your standard forecasts. You have to define that very, very clearly. If you do not define that clearly, then all the other decision-making that you have to make through the next 9 steps becomes more difficult. So the first 6 steps are fit for purpose, and the last, and steps 4 to 10, actually are where we work through the fit for budget. But at each step, each decision or decisions that you make in each of those steps actually play a role in what your total operational costs will be on an annual basis. Next slide, please. So when we're defining fit for purpose, specifications become a very important factor in not only your capital costs, but your ongoing operational costs. They become the foundation, the specifications that you set at the tender specification portion become the foundation of your data. And you have to be cautious when setting tender specifications. And we're going to look at tender specifications, or we'll talk about, in this case study, what it takes to run a network of synoptic automatic weather stations. Typically, when we set specifications, we set them for individual components. And we need to start looking at adding together the system components to make sure that we're actually hitting the true system uncertainty. The World Bank, WMO, and HMEI got together several years ago in partnership to develop tender specifications. And I believe a subset of these specifications that were published are now being used by GBON and the SOFT initiative. And so when you say that you want to have, say, 60 synoptic automatic weather stations, you don't have to create those specifications. They exist already. Next slide, please. So when designing the observation network, some of the biggest impact, both on the capital side and on the operations side, is when you design your observation network. You look at it from a GBOM point of view, and that will tell you the number and optimal spacing of stations. But that may or may not become affordable. You have to look at the logistics of the locations. What is it going to cost to bring in the utilities, power, etc.? And one of the key pieces is site security. You have to be able to have secure sites where you're not having to replace equipment or where damage is occurring frequently. One of the keys is, and David talked about this earlier, can I partner with other agencies? And it's not only the data being shared by the Met Service back to others, but is there other data that exists in the country that can be used that is of sufficient quality, fit for purpose? Those are areas where you can save money or where things become more expensive, especially when locations are very remote. When defining the network data management plan, you need to understand how you're going to ingest all this data, the frequency, where the data will be processed, and who's going to require the access to all this data. All these have costs both on the capital side and then on the operational side. Next slide, please. So defining the infrastructure requirements for a network of weather stations is well known. You have to have flat land, you have to have a certain area of fetch so that your data is, especially for wind, is not affected by tall objects surrounding the stations. But it comes down to what site preparation needs to be. Mostly under the initial, most of these costs come under the civil works, under the initial investment, but site security, utilities, and if you have to lease land, will impact the ongoing operational costs. Next slide, please. So defining the operational requirements, this comes down to the annual maintenance and the frequency of site inspections. When you have a standard automatic weather station that has air temperature, relative humidity, wind speed, direction, solar radiation, barometric pressure, and precipitation, some of those sensors require frequency of cleaning, like the solar radiation sensor lens, the radiation shield for air temperature, and especially in the tropics, the rain gauge, where debris and insects tend to plug tipping bucket rain gauges frequently. And so you need to look at how you're going to take care of those maintenance issues that happen on a daily or weekly schedule. You have to schedule preventative maintenance visits with qualified technicians that understand the system and can recognize when things are starting to fail or may fail so that they can do that preventative maintenance to ensure that the data flow continues in a sustainable manner and that you're achieving that 90 to 95% performance level. Data quality can only be maintained on the sensors with a calibration frequency suitable for that sensor. Rain gauges need to be calibrated at least twice a year. Solar radiation sensors, usually once per year. Relative humidity probes should be calibrated once per year. Wind speed and wind direction tend to be easier simply because you can calibrate those or return them back to manufacturer specifications by doing simple maintenance of replacing bearings, etc. There's also unscheduled corrective maintenance, and that requires quite a bit of planning of how you're going to handle certain stations. If the station is extremely remote, how are you going to how long can that station be down without transmitting data back to your central server? You need to have a plan and understand how you're going to deal with, and you also have to budget for unexpected downtime of equipment. Adaptive maintenance plans are more geared towards upgrades to server systems, but you have to be able, and they don't happen frequently. I believe AWAS is probably the best example here, where ICAO every 2 or 3 years will release new standards, and you have 2 or 3 years to upgrade your systems to meet those standards, and that would be an example of an adaptive maintenance plan. And then one of the biggest things that we see that is this life cycle management plan that is not occurring where systems are not sustainable. Next slide, please. So David talked a bit about this life cycle management plan, and this is depreciated value of a standard weather station that costs $50,000 US for its initial capital. If you look at the orange line, that the depreciation basically goes to zero in 5 years. And the reason for that is that if you do not do any life cycle management of the site, then things like the batteries, the air temperature relative humidity probe will fail. There may be ICT or computer upgrades that you need to do to your server network. And if you don't do any of those things, then you will not get any data. And the true value of the weather station now is zero, because it's not delivering what its initial capital investment and design was supposed to do. But if you do a modest investment of probably about $2,000 a station at that 5-year point, you can actually increase the value of the station and continue it on down to the full 10-year lifetime of a weather station. But when you consider that the equipment today is now of sufficient quality and robustness, you can actually start to look at, maybe in year 8, you have to make some decisions. Do we replace our network at year 10? Or do we do another life cycle investment and extend that life to 15 years? And I would strongly suggest that you start to look at the reasons why you would want to continue on with the existing equipment. If your communications is still valid and working, as well as if the stations have proved to be robust and reliable and hitting that 90 to 95% level of performance, then I would suggest that you take a look at doing another life cycle investment at year 10 and extending the life of the equipment to 15 years instead of the standard 10 years. Next slide, please. David talked a bit about the number of FTEs required, salary and training. It's difficult to give a complete guide as to how many technicians, field technicians, you're going to need to run a network of 60 weather stations. And the reason it's difficult is each country has its own logistical challenges. Certainly in Canada, where I'm from, there are some significant logistical challenges in trying to get to the far north. And sites are quite often remote, even in the lower part of Canada. But typically it's a number of one technician can take care of 10 stations. So perhaps you would need 6 technicians. It also depends on how frequently you're going to visit each of the sites. But you have to have local system operators and data scientists. And that group of people, along with the IT specialists, can provide more value with the data in looking at how you can get other data products, advance your forecasts, and get more information out of the data that you're taking. I talked a bit about at year 8, starting to look at what are you going to do at year 10? Are you going to replace your network, or are you going to do another investment? Network management and planning is a constant, and it does take a dedicated individual to put that together. And then, of course, you need your operational support for 24/7. David talked about determining the most effective business model, and I would add that because you select a business model does not mean that that business model doesn't evolve into something else. For example, if you were to use a government-owned, third-party operated, because the National Met Service does not have either the staff or the training to operate the network, use a third-party operated business plan, and then look at how you can develop an exit strategy as the National Met Service gains the experience and the necessary technical knowledge to operate the system. Look at how over time you can, where the National Met Service can actually take over the network and the third-party operator actually exits out of the program. Next slide, please. So when you go through a case study for a network of synoptic weather stations, it represents a great deal of work and requires strong project management. One of the FTEs that was not listed is a project manager, and the project manager is involved from step 1 all the way through to step 10. In step 10, once you've made all your decisions and done your network plan, you can start putting some costs together, sort of the initial investment costs, the annual operating costs, the life cycle management costs, and at the end, there's a total cost of ownership. On the right-hand side is the total cost of ownership summary form, which is part of the meteorological section. And I strongly encourage you to look at, when you've done your network plan, figuring out what all those costs are. Even if you don't get it right and you get it 50% right, at least you have advanced your understanding so that you can take it further as you learn. And you'll, if you get to the end of the total cost of ownership and you are targeting 60 stations in your network, but you find you only have an operating budget for a third of that, then I would strongly encourage you not to buy the 60 stations and work through the process of deciding which stations you can do without in order to have a sustainable network. Otherwise, we will find ourselves back in the position of developing networks that are not achieving the results that we expect. And with that, I'll turn it back to you, David.
Yes, so in conclusion, the key points would be, you should create a roadmap for networks that are fit for purpose, fit for budget. Prepare a financial plan that aligns available funding either now or in the future at that of your national budget expectations. Consider the most appropriate business models. consider innovative financing schemes, such as how you might leverage partners as contributors to networks. Prioritize building human resource capacity and adopt the systems approach. And finally, observations are fundamental to providing significant long-term social, economic, and economic value, and finding ways to communicate the importance of observations to governments who are often the sponsors of these financial sponsors of these networks is important. So thanks very much for the opportunity for us to present today.
Thank you, David, and thank you, Brian. And now we are open for discussion and questions. So please feel free to ask your questions in the chat. Please feel free to raise your hand. And actually, I'll start with a question. This is going to be for David Grimes and for David Rogers, because you're both former heads of Met Services. How did you justify your national investment in these observations, which are far upstream from the services that you provide and sort of the clear benefit that you provide as a national meteorological service? David Grimes?
Yeah, okay. So simply creating the visibility with government and in the national budgeting process, stressing the importance of how data is actually quite fundamental to those services. And I'll give you two examples. It's pretty easy to communicate that without observational data at an airport, airplanes don't fly, you don't have the kind of business and commerce that governments depend on in having this kind of capacity. In case of hydrology, understanding water resources and how water resources are changing, also fundamental to observational data. So it's about communicating the value of the observations in a presentation, not just to stress, for instance, early warning services. Early warning services is a benefit, but it's not actually feasible unless you actually have the observational capability.
Thanks, David. And David Rogers?
Yeah, thank you. I think it reflects the maturity of the system in the country, right? So certainly past experience in the UK is that there is a notion of agencies sort of sharing responsibility. I mean, it was alluded to in the presentation that partnering with other agencies is very important. So, for example, radar networks in the UK, they're not operated by the Met Office exclusively. They're part of a network, and it's funded and supported by quite a different number of agencies and users. And I think this is part of what's missing very often when you make a comparison between a mature, advanced country, which has effectively embedded itself within its government structures. So we're not arguing for visibility. We have visibility. We don't need more visibility. What we need is a recognition that you need to invest in the total organization, and that this total cost of ownership is an example of that. And if I might digress a little to looking at, because I also work now mostly with developing countries, and there is an issue. We've just talked, Brian and David have talked to you, pretty much probably most of you from meteorological services. You probably have a pretty good idea of what your needs are, but you're also not in a position of making the ultimate decisions from an investment point of view. Very often, the government has gone, for example, the government may go to the World Bank and it's asked for a large investment, which it gets. It's borrowed money. It wants to invest in the meteorological service, hydrological services, and others, but it hasn't, as a government, at that level, in the planning department, national planning department, for example, they haven't really thought through this end-to-end, that by adding new capabilities, it's going to cost you more. It's not going to cost you less. Invariably, it will cost you more to operate those things for a long period of time. And that is not factored into the decision process. And I think this is something that I would appeal to WMO. That's a kind of a role of WMO to help engage fully with the government above, to help the DGs of Met Services to fully explain what is needed. So rather than a huge amount of money placed on the table, you will buy 100 automatic weather stations, umpteen upper air stations, and you have that budget, capital expenditure budget, but you have no way can you operate that. And it's very hard to look that gift horse in the mouth. So despite Brian's desire that you don't buy that many because you know you can't operate them, you will buy the ones that are offered or you will acquire the ones that are offered simply because that's the way the system is working. And the final comment I'd like to make related to that, which again differs from the way we operate things in a developed, advanced sort of economy, we're dependent on a lot of other development partners. They also need to get this message. They need to understand how this works. So when another bilateral relationship between a development partner and a country exists, and there's an offer of something, that offer has to work within the framework of what was discussed today. It rarely does. It is usually to look at Brian's model of those three graphs of depreciation. It's usually the left-hand side where things rapidly depreciate because those items are seen as a gift. They are not built into the operating budget of the organization, and they end up simply, they reach an end of life very, very quickly. Thanks.
Thanks, David. Let's take a question from Pascal Waino in Tanzania. Pascal?
Thank you very much for giving me the floor. I'll just have, mine is not really, the question is just rather a contribution. Or rather first, thanks for the presenters, for the issue that they've presented, especially the issue fit for budgeted and that we've seen in establishing a network. But I would like to just mention one problem on listed development countries and small state islands, that some of the investment, they are not sustainable. It's not because of the willing of operating them. It's just some of them are just operating to fulfill the global compliance of data sharing. But the countries themselves are not using this data, and they don't know how to use the data, especially the upper air observation. They just launch the exchange and business continue as usual. So themselves at the Met Service, they don't see the values. I mean, if these lead global centers would have demonstrated the case that if we don't receive the upper air from region, what effect is it going to do on your weather? Because they also receive the information from these centers. So they need to understand that what contribution this observation they are doing add value to their jobs. If they don't know that, simply the small problems with hydrogen generator, they'll stop generating it. If there is small problems with the consumable, they'll stop, doing these upper air observations. And when you don't operate upper air observation for 6 months, you want to reestablish, it will definitely cause a lot of problems. It will require a lot of money to revive the operations. So I think another issue is to ensure that this in the budget, that not only investment, but also these countries, what added value with this automatic weather station, with this upper air station due to their network. And if they are missing them, what are they going to lose? If they do understand that, I think that part we are missing it. And most of the time, we don't communicate the local, the importance of this data. How is it going to add value? So that is also very important, especially for less developed countries and small state islands, to understand the value of this observation network. Even though they're not doing data assimilation, but when they exchange it, there's added value that improving their forecast of their region. So I thought that's a small issue that is not being paid attention a lot. And I thought in this forum, it's right also to raise it up so that if the awareness starts from the place where the observation are done, then the sustainability part is going to take a place like in aviation. We've seen the good example there. Thank you. I think I'll end up there.
Thank you, Pascal. That's a really, really important comment. And in fact, one of the criticisms that's been leveled at the combination of GBON and SOF, which focuses only on the observations. And I fully agree that it has to be hand in hand with investments that actually yield at the country level some benefit from these improved weather forecasts and use of these forecasts and delivery of services. Otherwise, we're not really looking at the full infrastructure value chain. But I wonder if maybe our speakers would like to respond to that.
Yeah, I could make a comment. You know, centers having operated Canada's, and Canada being one global center, we do data denial studies where we have data, we take data out and then we look at where are the gaps, and so it is quite possible to actually demonstrate the value of when you take data away, the value that upper air data provides to models. And most modelers that manage these modeling systems actually will communicate that their primary data set is upper air for ensuring the integrity and the performance of these models going forward. So I think it's an easy question to answer. And I think WMO actually has the capacity to kind of organize. You don't have to do it everywhere. You just need to do it in a few places just to show that the value. And there have been published studies as well on data denial showing the value of upper. I know that ECMWF had done something a few years back showing the value of upper air.
Thanks, David. Any of the other speakers, Brian, Vladimir? David Rogers.
Yeah, just to add to David's comment, also from a verification point of view locally, there's, I mean, and this is part of what ECMWF has sort of been working with a few countries that we've been working in, where you really need to help the country know how to utilize the models that exist and verify those models, even if those data that they may be collecting are not integrated into the global network. So there's two aspects. There's more sharing of data, certainly upper air data, which is we know has a big impact in terms of improving model performance, but also model performance is also improved by that data, often a huge amount of data that exists in the country that is not integrated into the model suite. But if it's known how to do verification properly, it is extremely valuable because it also bias corrects and does all sorts of other things which help both the global modeling community, but also the country itself in utilizing the model products more effectively. Thanks.
Vladimir, I see your mic off. Go ahead.
Yes, thank you. Just to add on the top of our two experts, indeed, upper air is the most visible and most valuable about land-based observation, and that was reported through the study jointly developed by the bank, WMO, and DCMWF a few years back, and that was, by the way, one of the fundamentals of the SOF program. But I wanted to mention this connection between any data which is collected by NMHSs or any other source of generation of data in the countries. It might be considered as a part of this global public good. And I think David mentioned it a bit because it goes into this climate records, which are very important for multiple global and national and regional user needs. And just to let you know that the bank is jointly with a number of academic institutions in developing new study of socioeconomic benefits of data. So I hope that in 2 years we can just give you another insight. I mean, share, of course, with WMO this new insights which are showing this global value of data, all sorts of data and application to different sectoral needs as well as to early warning system. Thank you.
Thanks a lot. Let me ask you a question that's come up in the chat from Carl Monik of the Bureau of Meteorology. And I think he's talking about largely bilateral foreign aid investments. I've observed that many foreign investment decisions aim to use their own national technology as investment into the beneficiary country. Beneficiary countries sometimes ends up with a wide range of different technologies, which is difficult to support. So how can those investments be directed at technology that is generic and sustainable? And maybe I'll start with Brian from HDI.
That's a really good question, and I think I would go back and start at even beyond the basics of design of systems and networks, because quite often countries end up with a lot of disparate types of technologies, and not just within a national Met service, but within hydrology, within agriculture, within renewable energy, transportation. And I think one of the areas, especially in countries that are starting to build their networks, to look at maybe a complete monitoring strategy for the nation and look at how you would implement the different pieces. Quite often, and as an aside to the question, quite often we see a lot of duplication between agriculture, hydrology, and national Met services, where there are 3 stations almost co-located. And it's very expensive to maintain 3 stations when one would have done the job. And so looking at national monitoring strategies and the technologies that they require, and you don't always have to have the latest and greatest technology. Sometimes the tried and proven technologies are just perfect for what a country needs to infill its data set to support its forecast and early warning systems.
Thanks, Brian. Does anybody else want to join in on that question? Vladimir?
Actually, from our standpoint, it's a tough one, because if countries borrowing from different international institutions, which is often the case, it's difficult for countries sometimes to argue. What of course we can suggest is that countries should, first of all, as was mentioned by colleagues before, look at the existing networks, and if existing networks has a dominant supplier, then they should convince whoever is organizing procurement, whether it's a World Bank or UNDP or others, that they should be responsible for developing technical specs which will fit existing network, and it will fit the profile of their staff who would be familiar with that technology. But otherwise, what we see in many countries, that they have indeed this patchwork of different networks, and few people know how to manage that. Sometimes in the worst case scenario, and I've seen that also in some countries, when initial investment failed, I mean, the networks are not functioning for the reasons which was described, the next investor comes and they bring another new system with completely different set of stations, completely different technologies, and that there is sometimes a sequence of this modernization which doesn't bring too much good results. So ideally, and that would require, of course, WMO cooperation and support. It's developed this monitoring plan which would be acceptable, probably acceptable is the wrong word, which will be supported by various developing partners. So that would be an ideal situation. Thank you.
Thanks, Vladimir. Let me ask a question, actually back to you. because both David Grimes and Brian talked about possible public-private partnership models. Do countries in general that you work with have the right legislation, kind of procurement systems in place to be able to deal with those kinds of models?
Is it a question to me or to colleagues?
I think to you, for the most,
Well,
in terms of working with countries.
in most countries, this does not specify it clearly. We're actually finalizing a description of this legal basis. WMO also has Kimura-san developed some of the analytical pieces related to that. But overall, there is a lot to do in reducing these obstacles. Now it's more problematic in many countries, including some where it is explicitly prohibited to do anything in this area except for NMHS. And those who sometimes enter into this market can be criminally punished. So that is extreme case, of course. So, and therefore, again, jointly with WMO, we will be happy to make a case that building proper legal regulatory basis in this area for facilitating public-private cooperation is a very important future development.
And let me, we're running out of time, but let me ask one last question from the chat, which comes from Mr. and Mrs. Green from Bahamas, which is a question really about an impact from an extreme event from tropical cyclones. Is there something that countries can do to plan and bank for such sort of disasters that wipe out parts of the network and need sudden investment to bring them back?
Well, maybe I'll take first run at that. It's difficult because it doesn't seem to matter what country you're in, where you can be impacted by extreme events that have an impact on observation equipment. I also recognize there are other issues, not just about maybe getting equipment, but it's also the cost of travel to go and replace them. There are other factors that are important. Certainly, there are disaster relief funds. Often, there's a call for those, and I wonder if, in trying to define, what would be eligible contributions that let's say uses of those funds would be could be one way of recognizing this as being foundational to a country's well-being. If you've made that kind of connection, then restoring that capability is important. This is pretty evident in an airport system, because the country has valued international travel, whether you're a small island developing state or lesser development country, because of the way products, goods, and services move out in using aviation. So, thinking about how to characterize the importance of observational systems as part of restoring capability of a country after it has had a devastating impact would be important. Also, working with insurers. That, like there are various parabolic insurance, for instance, which can be used to kind of support, a country to sort of rebuild. It's another example where I think WMO could play a role in helping to define criteria that could go into those kinds of events, which would allow then countries to get the financial resources they need through various means to support that.
Thanks, David. We have run out of time, so I'm sorry we haven't been able to take all the comments and all the questions. I want to thank our speakers. I think this work has been really timely. In fact, in the context of GBON and SOF, where peer advisors and beneficiary countries are starting to develop their national contribution plans. So let me thank you, David Grimes, David Rogers, Brian, Vladimir, and thank you to our audience for sticking with us through this way. It's been really useful information. We are repeating the same webinar on the 19th of June. It's the same webinar, but you can join again if you want to ask your question again. Thank you very much.
Okay. Thanks. Great.
Thank you,
Thanks. Thank you, Albert, for facilitating this.
Thank you very much. Bye-bye.
Bye-bye.
Bye.